All right, in this video, we are going to talk about a program called Git. All right, Git. And what Git is a distributed version control system. So, version control, right? What that does, a version control system, excuse me, it allows you to track changes in your software project over time. Okay, so um, let's just say you were working on your project and then you made, kind of a big decision about something, and you made a bunch of major changes, and you start working on those major changes, and then, you know, you get a little farther down the road in the project, make more progress, and then you decide, or you suddenly start thinking, hey, maybe that was a mistake. Maybe I didn't want to um, make all these changes. And you kind of want to go back and scrap those changes and go back to the way you had it originally. So unless you had saved, a version of the original before you made those changes, then you'd kind of be stuck. You'd have to go back and scrap everything you did and go back and fix those changes. So what a version control system does, it allows you to track all of those changes that you make in your software project over time, so that if all of a sudden you decide, hey, this is maybe not the way to go, you can roll it back to a previous version without, it's pretty much automated. You just roll it back to the previous version. So it makes it really easy to revert changes like that, and just keep track of the minor changes that you've done to your project over time. So, all right, and so that's what a version control system is. Git is distributed, right? So what that means is that every the full history of the entire source code of the changes that's made, right, is kind of mirrored on every computer that you're on. So, for instance, I switch, or well, used to switch around computers a lot, traveling back and forth, and so it's kind of irritating if you've got like an old version on one particular computer of some project that you're working on. So you have an old version on the computer that you're currently at. With Git, what you can do is just have the entire project in its fully updated state on every computer that you use. And if you're working in a team, you can have it on every developer's computer. So some version control systems have sort of a central place where all of the code is kept, and it all has to be done in that central system. But Git is the opposite of that. It's distributed, meaning that every person has their own full copy of the source code, and the full history is available for every computer. Okay. Git was created by Linus Torvalds in 2005. Linus Torvalds is the same person who wrote the Linux kernel, the original one, way back in the early 90s. So it was developed by him. And I think part of the reason why he developed Git was to facilitate work on the Linux kernel by lots of different people contribute to that. So it was that was the original intent, I believe, to help facilitate work on the Linux kernel by multiple developers. Git is free and it's open source. It's licensed by the GNU GPL version 2. License. And you can go to the website here, and it will tell you a lot more about it. All right, and you can see a lot of major companies use it in their development process. Okay, so that's what Git is, basically. So some of the benefits of using Git, we already talked about that. It allows you to use use version control on your software projects. You can track changes in your files, revert changes, create multiple separate versions of your project. Okay, and so a lot of times that's what will happen. You'll have a sort of a development branch and a production branch, and then the developers will work on those development branches, adding new features, and then those features will get incorporated back into the master branch. It also facilitates work on projects with multiple people, so you can incorporate those changes from multiple developers into a single project. Like I said, there may be multiple development branches, teams of people working on different features, and then you can drag those features back into the main version of your project. All right, before we go into some more details about Git, we need to talk about places like Bitbucket and GitHub. So Git, the program, and Bitbucket or GitHub, they're two different things, okay? So Git is just a program that runs on your local computer. That's it. It's really just a command line program, but there are front ends developed for Git to make it a little easier to work with. What Bitbucket and GitHub provide is cloud storage of your code. So it's you can store your code in the cloud. They're not only cloud storage, but they provide support for projects using version control systems such as Git. So there's tools and stuff that are integrated with Bitbucket and GitHub that you can use to facilitate that. GitHub also has a sort of like a social networking capacity. You can follow other people's projects and things like that. And Bitbucket is a little bit more focused on professional teams with proprietary software code. So I had a GitHub account before I had a Bitbucket account, but one super nice thing about Bitbucket at the time was that you can have unlimited private repositories for an educational account, for a free educational account. So that's why I wanted to go with Bitbucket as opposed to GitHub. Probably GitHub is more out in the open, but for school purposes and teaching purposes, I needed to have a place where I could keep that stuff private, for various laws about not exposing student work to the public. So Bitbucket for free gives you unlimited private repositories. That's why I asked you to sign up for Bitbucket with your Dalton State ID or Dalton State email account. GitHub may also do that, but back when I was first trying to incorporate this into my classes, Bitbucket was the only one that gave free unlimited private repositories for educational purposes. If you are considering software development as a career, then you definitely should create a GitHub account and start putting your code there. So prospective employers can look at it, and you can network. Some people might see your code and say, hey, that's great, and you might make contacts that way as well. So that's definitely something I would recommend. Bitbucket, you'll see, because of the private repositories, it's more along the lines of proprietary software code, like companies and stuff that don't want to expose their code to the public for whatever reason. So okay. So just make sure that you understand those are two different things. Git, right, it's that program that runs on your computer. It basically sits there and watches the changes to your files in your software project and keeps track of all those. Basically, almost like a little database of your project and how it's changed over time. And then Bitbucket and GitHub, right, are cloud storage of your code. They have these tools that facilitate the use of version control systems. All right, how does Git work? So this XKCD comic kind of summarizes it in a pretty good way. It says, this is Git. It tracks collaborative work on projects through a beautiful distributed graph theory tree model. Cool. How do we use it? No idea. Just memorize these shell commands, type them to sync up. If you get errors, save your work elsewhere, delete the project, and download a fresh copy. So it's funny because that happens a lot. Sometimes you do get into situations where you're not quite sure what you did, and you'll get some conflicts and stuff with Git. But especially if you're starting to use it, so just be careful about how you use it. Again, if a bunch of things go wrong, then you can do exactly what this guy says, right? And that is just move your work to some other place, save it, and then delete the project. Just download a fresh one and start over again on there. But try to do things the right way and not rely on that. So anyway, so the first idea that we need to talk about with Git is the idea of a repository. So a repository is a data structure, among other things, that contains the information about how a specific collection of files has changed over time. So you'll have the files that make up your project. You might have different .java files. You might have some database files and other things of that nature. And so the repository is basically like a little database that keeps track of how those files have changed over time. Okay. And it just usually resides in a directory in your on your computer or in the cloud storage. So there's two kinds, a local and remote repository, that are convenient to think about. A local repository is just a repository that's stored on your computer. It's generally just a folder, and inside that folder is the information that pertaining to whatever collection of files is being tracked in that directory. All right, and then a remote repository would be one that's stored on another machine, or Bitbucket, or GitHub. All right, the next idea is the idea of a commit. All right, so a commit or a commit object contains, among other things, the files in your repository as they appeared at a given moment in time. Okay, so you can think of a commit, right, as taking a picture. Like, say you have a bunch of files that make up your project, a bunch of .java files or whatever else kind of files in there in your project, and you take out your phone and you take a picture, right, of all of those with your phone. And so you have this bunch of images, and that image has information about all of your files as they are at any given moment in time. Okay, and so then you say have those photos and you save them in the repository. So the repository will have a picture of all your files at that instant in time. Then you make some changes, right? Add a few things, maybe delete a few things from your files, and then you'll do another commit. So you'll basically take a picture, right, of all of those files again, right, and store those in the repository. Okay. All right, so that's what a commit is. And every commit except the first one has a parent commit. So you're going to make an initial commit, right? And then you're going to make another commit. You'll make some changes and make a commit, right? And so that second commit, right, is going to have the first commit that you made as the parent commit. All right, so that's the commit that you changed. Right, you changed the files at that moment in time to generate the second commit. All right. So the parent of a given commit is the commit that was edited to produce the new one. All right, the new commit. So any one moment in time, your files were a certain way from some commit. You changed them a little bit. Then you made another commit. That second commit is the child of the first commit. And now don't confuse that with inheritance that we were talking about. It's sort of different. Okay, then we're just talking about repositories, not Java classes or anything like that. All right, so first off, we're going to talk about the basic single user workflow. So this is the probably the most basic workflow that you can get using Git. It's only using a local repository. Okay. So what you would do in the basic single user workflow, right, is to create a repository. I'll show you how to do that in a minute. And then make the initial commit. Then you make some changes to some files, and then you commit your changes. All right. So that you would do your work, and you do a little bit of work, and then commit your changes. And then do some more work, commit your changes. Do some more work, commit your changes, and so on and so forth. Okay. And that is going to be how the basic single user workflow works. So you'll have a local repository on your machine, right? And then in that local repository, it will track all of the changes as you work through your project. Okay. All right. And now this also doesn't include, right, using Bitbucket or GitHub or anything like this, and we'll talk about that in the next video. All right, some advice on Git. You'll hear people say commits are cheap, right, or commit early, commit often. So what you want to do is not make just huge, massive changes in between commits, right? You would, add some code, add a feature or something new to your project, and then make the commit. Okay, if you try to make all of the changes at once to your project, then you're kind of defeating the purpose of this by tracking these incremental changes. It's going to be a lot harder to roll everything back if you need that. So commits don't cost anything, so you commit before making too many changes. All right. So if you don't do that, you're really kind of defeating the purpose of version control. You're gonna make it harder on yourself if you want to revert those changes. The other thing, and this is required whenever you make a commit, right? Then you're going to have to type in some messages before you commit. That's required. Make useful commit messages, right? Because if you need to roll back, it's a lot easier if you make these useful commit messages to find the version that you're looking for. If you have 50 commits or something like that, then it could be really difficult to track down the changes. The minute you find yourself in that situation where you're hunting through a bunch of commits, right, trying to find the right one, you'll really thank yourself for making useful commit messages. And that has happened to me, plenty before, when I had a bunch of changes, like the changes that we used, or all of the code that I put on Bitbucket, I do this way, right? For you to look at the example code, the code that I use in the lecture. So sometimes I'll make changes, sometimes Java changes, or I want to find a better way of doing things, and I want to redo those changes. Every now and then, sometimes I'll make a mistake and not do that in a correct way, and then I've had to roll things back, and rather than from scratch do things, you're really thankful when you have useful commit messages and you can find the right commit that you want to turn back to. Okay. All right. So there's lots of different ways in which you could use Git on your computer. So all you really need is a shell. If you pop up in a command prompt, right, or PowerShell on Windows, or terminal on Mac OS or Linux, right, that's all you really need to run Git. If you use GitHub or Bitbucket, they do supply some Windows-based tools, GUI-based tools to use Git as well. Since we're using Eclipse, we're going to use eGit. Eclipse ships with eGit, so it's kind of built into Eclipse. It has all of the tools that you need to use to track use Git to track your projects. All right. The documentation you can find here: help, documentation, choose help contents, eGit documentation. It is a little, it's okay. You can look through there. Right now, we're just going to use the basic functionality of it, and then we'll add a little bit more as the course progresses. All right, so First off, setting up Eclipse to use Git. I probably need to show you how to do this. I need to go ahead and get rid of it because on mine because I already had it set up. So to show you how to do this, so first off is Window, Show View, and then Other. And then here's will probably look like this. You just scroll down to Git and expand Git, and then you want Git Repositories, and then Open. So that is going to open up this window here, Git Repositories. When you open yours up, it'll probably be blank, right? On mine, I forgot I already have this one here, so I'm going to remove that. No, I don't want to do that. That's what I want to do, remove repository from view. So when you start up, it'll look like this, okay? So here you'll be able to see all the Git repositories that you make. Next up is the Git staging, and that's similar to what we just did. Go here to Window, and now this might be slightly different on a Mac. Show View, Other, and then Git staging. And that's going to pop up another tab down here. All right, and that's where changes that were made to your files are gonna show up here. You'll need to stage those files and type in your commit message, and then here's where you can commit your files. So this is the mechanism by which you'll be committing things, or one of the ways in which you can do it. The other thing is on show history. I don't have a project open right now, but if you right click on project and then go to teams and then show history, then what will happen is you will get another tab down here, and in that tab you can see the history of the changes of your the various commits that you've already made. Okay, all right, so all right, so we're going to work through this. Normally we would be doing this in class, but I'm going to just work through it so you can see how it goes, and you need to work through this on your computer as well. All right, so it says first thing is to create a new local repository. All right, so let's do that. So go here, File, and then New, and then Other, and then Git, and then Git Repository. All right, and so click on Next, and then here, let's see, did I have a specific name? Okay, so right here it suggests a directory in which the repository is going to be stored, right? So this can be basically anywhere. Here you can see it was in my home directory under Git, and then repository. So you can put that basically anywhere you want to by clicking on Browse, right? And here I'm going to rename it to My Projects. On a Windows 10 machine, it'll be C:\users, then your username, and probably Git right here, and that's a good place. Don't use your Eclipse workspace. Choose another directory to do that. That's one weird thing that can happen. So I usually just use this Git or a different location, definitely a different location than my Eclipse workspace. All right, and so I'm going to call it my_projects here. So I would go to Browse, and then I have to go to that location, Git, make a directory here. My projects, and then click on that. All right, and that's the location where I'm going to keep all of my projects that I want in this repository. All right, it should show up here under My Projects. All right, and so if you can expand it and look at some things, we won't talk a lot about that right up front. All right, but you should see your repository right here. All right, next up, create a Java project called Hello Git project. And now when you create this new project, right, what you want to do is set the location to a directory with the same name as the project inside the directory where the repository is located. All right, so what you would do is go into here, into this directory, wherever, you don't have to put it in the same location as mine, but wherever you put it, whatever directory your repository is in, go into that directory, make a new subdirectory under that, and that's what you want to choose to be the directory where your project is. Okay, so I'm going to go here, File, New, Java Project. I'm going to call this project Hello Git Project, and instead of using the default location, again, extremely important, right? Unclick that, go to Browse, go into your repository. All right, here is the repository where I want that project to be located. And inside that repository, put a new directory. Like so, create it. And then select that folder. All right, so again, make a folder, a directory inside of the repository that you created with the same name as the project name. So, all right, and then I am going to just click next. I don't need a module .info -info. All right, so I have a new project, right, that's created, and you can see if you're on this Git staging, you can see that there are some files that have been added, right, to this down here in the Git staging. If you look there, you can see there's some unstaged changes. Sorry. So what that is Git, right, is just sitting there watching the directory and said, oh, wait a second, now some things have changed. So Git makes a note of that in this Git staging. So here's the things that Git said have changed. All right. All right. So let's see. All right, I'm going to add a class named Hello Git to the project. So here I would go under source, new, class, and for package, I'm just going to choose application like I've been doing, and then Hello Git, or whatever name you want. I'm going to add a main method to it. And then, so now I have a class here. Okay. All right, and then save it. I guess it's been saved. Okay, so save the project. Then go back to the Git staging tab and double click the plus icon. So what we'd be doing now, right, is basically making a commit. Right, so we want to take basically a picture of the files as they are. So you would go down here. These are the unstaged changes. You would double click this double plus icon down here. That would stage all of your changes, right? All of the changes to your project now are ready to get committed. All right, and then you would make a commit message. So this is the first one, right? So usually you just say initial commit or something like that. All right, and then you would commit, press this button down here, and that will commit your changes. So basically now Git has a snapshot of all your files as they are at this moment in time. All right, and you can see all of the, there's no unstaged changes, right? Those are all been committed. So next up then is I want to go back and show you just give it a second. I want to go back and show you this history now that we have a project, right? We can show that history tab. So if we go right click on your project and then do team and then show in history, you'll see this tab pop up, another tab, history, right? And then you can see that your commits. This is a history of the commits that you have, okay? And we'll talk a little bit more about all of these things in a later video. Okay, so now what I want to do then is going back to this, man. Oops. So we've made our initial commit, right? We've got the history tab. You can look at the information there. So I'm going to add some more code and then save the project again. All right, so add some more code. All right, so I've added some more code, and now generally you're not going to do it for every line, right? Like I'm doing this in this video. Just it needs to be, bigger chunks of code than that. So you don't want to be doing it for every line, but you don't want to wait too often either, right? It costs nothing to commit. So here I'm going to save, right? And then if I go back to Git staging, you can see, hey, I have some unsaved changes right here, okay? So what I'm going to do is, I think that's what I wanted to do. Yep. So I want to commit my changes that I've made. So click the double plus. That adds all of the unstaged changes down here. You can just do individual ones with the single plus here. All right, and then I'm going to make a commit message. All right, so here's my message, and then now I'm going to commit. All right, if I look in the history now, I can see, hey, my initial commit, that was the one that I did the first commit, right? And then I added some more code. I made another commit as well. All right. And let's see if I can just repeat that a few times. So add some more code. Again, you don't need to do it after every line. I'm just showing you how this would work. So now I've got some more changes. I want to make another commit. Click the double plus to stage all of those commits. A message. And then commit. All right, looking at history, now you can see I have 3 commits right here, okay? So you can see track record of all that. All right, so looking at the history, you can see the different commits in there, all right? And you can add some more code to there. All right, and so basically that's how Git's working. You can track your changes as you go through and make these changes. Now, let's say that you want to revert back to the changes. I'm not going to, this is not exactly the right way to do it, but just to kind of show you how this would work, right? If I double click on this second commit down here in the history, you can see it kind of compares the differences in these files. You can see it shows you what the changes were from this one to this one as well. All right. So you can do that. Let's say if you right click, let's say the second commit right here, and this is again not the way to do that, but I got to be careful not to completely mess it up, but yeah. So if I go to check that out, you'll see I get this message. So I'm not basically doing this the right way, the correct way at the beginning, but I don't want to go too deep into this. I just want to show you this is kind of what it would look like if you went backwards, right? There's a better way to do what this is doing. You can see I've got this message. You are in the detached head state. That means you don't have a local branch checked out. So you generally don't want to be in that state. But this is so don't really do what I did. But just take a look. You can see that I went back to that second commit. All right, and you can see that line, that code that I added is missing in there. Right, it went back. This is what the files look like during that second commit. Okay, so now to get back, if you find yourself in that stage, just go to switch to up here, and then master, and then you're back kind of to where you are at that most recent commit right here. So you can go back and look at the files as they looked in previous situations. Okay, and so that's the basics of Git. If you follow this, all of your code changes will be tracked as you work through. Now, you don't really need this for a small project, so this is really intended for larger, more complex projects, right? But it doesn't hurt to have this available to you when you're working on your own projects, especially practicing the workflow. To me, that was kind of the biggest thing to get used to, is that when you're using Git, you have to kind of get used to how you're supposed to work with it. So it does change how you work with things a little bit, right? And there is a little bit of a learning curve in getting into the habit of, making commits and those sorts of things as you go through. But it is a useful skill to learn, and a lot of places use these version control software now, so it is something that you can kind of point to and say, hey, I have experience with using Git on these projects when you're going to potential employers. All right, so that's about it for this video. In the next video, I am going to show you how to take this project, right, and put it on Bitbucket. So you'll be able to use Bitbucket to host all of your projects that you're working on in this class.